This is Adi-Gas law calculations. The Adi-Gas law says that PV equal to nRT, where P is the pressure of the gas, V is the volume of the gas, N is the number of moles of gas present, R is gas constant, and T is the temperature of the gas in Kelvin. So in doing any Adi-Gas calculation, Adi-Gas law calculation, again, you have to convert to Kelvin. In the previous video of Charles' law and Boyle's law, we explained about how this Celsius can be converted to Kelvin. Okay. So common mistakes: expressing T in degrees Celsius, that is forgetting to convert to Kelvin first, using the wrong R, not including units in calculations. These are the common mistakes. So let's look at this calculation. Calculate the volume occupied by 0.765 moles of nitrogen gas at a pressure of 1.80 atmosphere and a temperature of 42 degrees Celsius. We start by to figure out what we know. Calculate the volumes, that's obvious, okay? That's clearly stated. Calculate the volume, we don't know the volume. We know the number of moles, 0.765 moles of nitrogen gas at a pressure of 1.80 atmosphere. Okay, we know the pressure, then temperature of 42 degrees Celsius. We add 273 to that. That will be equal to 311 Kelvin, because we must convert temperature to Kelvin. Looking at this, this is Adi-Gas law. How do we know? Adi-Gas law tells you about number of moles. And we don't have initial and final volume or final pressure or final temperature. That's clearly states means it's gas law. So that's PV equal to nRT. We have another challenge here. Which R is given? Which R are we supposed to use? There's atmosphere, there's moles. So atmosphere, moles. We are calculating the volume. We have the, so we are using the first one. So we are solving for V. So we divide this by P. So V will be 0.765 moles times, we are using 0.0821. When you write this, please make the unit clear. The unit has to be clearly stated. Don't write the numbers without the units. That's not acceptable. Kelvin, all divided by pressure, which is 1.80 atmosphere. Now we cross this out, we cross this out. We cross Kelvin, liter. We are calculating the volume. So moles, more we cross out. So what will the volume be? So we use the calculator to find out. Okay, this is temperature is not 311, it's 315. Okay, make that correction, 315. So this is 42 plus 270 is 315. I don't know how I got 311. So this is three significant figures. The answer will be in liters. That's the volume. 11.0 liters of the volume occupied by this moles of nitrogen. So it's 11.0 liters. So that's the example of Are they gas calculation? Are they gas law? So let's look at this question. A piece of dry ice, which is solid carbon dioxide with a mass of 28.00 grams, sublimes, that is solid to gas, into a large balloon. What is the volume of balloon at a temperature of 24.0 degrees Celsius and a pressure of 754 millimeter mercury? Okay, note 1 atmosphere is equal to 760 millimeter mercury. That's the equivalent statement. So we have two R values given. So we have number of grams. We look at number of moles. How do we have N? We know grams. So grams of carbon dioxide, we know that is equal to 28.00 grams of carbon dioxide. So, and then into a light balloon, what is the volume of balloon? Volume of balloon, we don't know. At a temperature of 24.0 degrees Celsius, which we must convert to Kelvin. And the pressure of this. Wow. A lot of conversion here. So pressure 754 millimeter mercury. So let's look at this. There's liter, atmosphere, mole, Kelvin. Can we get liter here? We are looking for liters. So atmosphere, that's we have to convert this pressure, millimeter mercury, to atmosphere. So we use this R. Then we don't have N, so we have to find the molar mass of carbon dioxide. So we've done a lot of molar mass, so we don't have to spend a lot of time figuring it out. So what is the molar mass of carbon dioxide? That will be, we want to calculate the number of moles, 28.00 grams of carbon dioxide. So you're using 1 mole equal to molar mass. We've done a lot of this. So mole of carbon dioxide, 1 mole over 44.01. We cross this out. That will be equal to 4 significant figures, 0.6362 moles of carbon dioxide. We got that. Now we have to convert this millimeter mercury to Kelvin. Okay. So we want to go to atmosphere. So that should be 754 millimeter mercury over 1. We are given this equivalent statement. We follow the same rule, millimeter mercury, atmosphere on top, 1 atmosphere, 760 millimeter mercury. Millimeter mercury cancel out. So we will be getting, the atmosphere will be 0.992 atmosphere. Now we plug in. Sorry about the mess. So PV equal to nRT. We are asked to find the volume. We divide by P, divide by P. That will be V equal to nRT. Do we have everything? I think we do. So N is, let me start from here, N 0.6362 moles times gas constant. Wow. I have to squeeze this in. 821 liter atmosphere over mole Kelvin. Times 297. I'm sorry. Times 297. All divided by 0.992 atmosphere. So here, I'm sorry for this mess here. This is N 0.6362 mole we calculated here. Then times the gas constant R, we are using liter atmosphere per mole Kelvin. Then times the Kelvin, temperature in Kelvin, which we calculated is 297 Kelvin. So 297 Kelvin. So this is a mess, but we have to manage it. Mole cross out mole, atmosphere cross out atmosphere. So this will be 15.6 liters. Okay, 15.6 liters. So that's the volume. 6.6 liters. So pause the video and try these 3 practice questions. The gas constants are given at the bottom. Try your best to see if you can get them right. Apply what we've been doing so far. So there are 3 questions. Read them carefully. The first one says, if I have an oxygen gas at a pressure of 1.4 atmosphere and a volume of 30.5 liters and a temperature of 85.0 degrees Celsius, how many moles of gas do I have? Let's look the first one. Look at the first one question together. Let's do it together. In that way, you check if you did it right. If I have an oxygen gas at a pressure of this. So in this question, we know the pressure is 1.4 atmosphere and a volume of 30.5 liters and a temperature of 85.0 degrees Celsius, which we should add this right away to avoid any mistake. N, how many moles? We don't know how many moles. Which R are we supposed to use? Obviously, this is PV equal to nRT. Very clear. We are given 2 values of R, which has one has atmosphere, Kelvin, liters. So we'll be using R, the first R value given. So we are calculating number of moles. So we divide this by RT to isolate N. So now N was equal to pressure 1.4 atmosphere times volume 30.5 liters divided by R. We are using the first R value given, 0.0821 liter atmosphere over mole Kelvin times temperature, which we change to Kelvin. So this cross out, atmosphere cross out, liter cross out. So we are left with moles. Remember, this is in denominator, so it has to flip. So our N, after all that, is will be 1.5 moles. 1.5 moles. Okay, I hope you did it correctly. Okay, so so the answer to B and C, this is 1.6 atmosphere, at 4 grams of nitrogen. I hope you try your best to get this right. Focus on the process, not the answer. Focus on the process, not the answer. Okay, thank you.